Hello, hello. So we are going to start today by reviewing a little bit about squares and square roots, things that you've heard before but we haven't talked about in a while. So if I say, what is the square of 3, or 3 squared? Well, that would be the same thing as writing 3 2 times being multiplied together. So 3 squared is 3 times 3, which is 9. Same thing, what is the square of 5, or 5 squared? 5 times 5, or writing that 5 twice, equals 25. So what if I want to find the reverse operation? What if I want the opposite of squaring something? What if I want the square root? So that's what we're going to talk about today, finding the square root. And sometimes our square roots are not going to be whole numbers. So what do I mean by that? All real positive numbers have 2 square roots. Well, in your mind, you're like, no, the square root of 49 would just be 7, right? Because 7 times 7 equals 49. Well, what else times itself can equal 49? What about negative 7 times negative 7? Does that equal positive 49? Yeah, it does. So the 2 square roots of 49, would be positive 7 and negative 7. So be careful, your calculator only gives you the positive, but we want both the positive and the negative versions of that. So how many square roots does a positive number have? Well, we just said it would be 2. So if you do in your calculator, if you think in your head, the square root of 36, well, that would be positive 6 and negative 6, right? Because negative 6 times negative 6 equals 36, and 6 times 6 equals 36. Well, what if you type in your calculator the square root of 13? It gives you like 3.6056 ... Well, 13 is a prime number. So if it's not a nice number, whenever you do it in your calculator, if you get an irrational number in your calculator, we want to do something called simplifying the radical. So for prime numbers, it's going to look different than other numbers, but for a lot of numbers, maybe we can't find 2 perfect squares, but we can get an answer that's not this crazy decimal by simplifying the radical. So how do we do that? Let's look at my first example. It says the square root of 40. So what I want to do is, what is a prime number that goes into 40? So how I write it is I write 40 in this little box. What is the smallest prime number? So we start with the smallest. Well, 2 is a prime number, and 2 goes into 40. Well, 40 divided by 2 gives me 20. So now 20 is in my box. Well, what is the smallest prime number that goes into 20? Well, 2 goes into 20 and gives me 10. What's the smallest prime number that goes into 10? Well, 2 goes into 10 and gives me 5. What's the smallest prime number that goes into 5? Be careful, this one's tricky. Well, 5 is a prime number, so 5 goes into itself and gives me 1. So when you get to 1, you know you're done. So now I want to circle groups of 2 outside of my factor tree or factor ladder. I call these things factor trees or factor ladders. Well, if I circle groups of 2 matching numbers, I have one group of 2's. Do I have any other pairs that are matching? No. So watch me now. This is kind of tricky. I take my circle of 2's and I put 1, 2 on the outside of my radical. And then I take the remaining numbers and I multiply them together on the inside. Does everyone see how I did that? I took my outside pair and I put it on the outside of my radical. I took all of my non-pairs and put them on the inside. Well, I can simplify that. What's 2 times 5? 10. So simplifying the radical of the square root of 40 gives me 2 times the square root of 10. So your answers are going to have square roots in them. They're going to look like that in the end. Typically, you're going to have a number on the outside of your radical and a number on the inside. Let's take a look at this one, 300. I'm going to start it up here so I have enough room. What's the smallest prime that goes into 300? Well, 2 goes into 300 and gives me 150. What's the smallest prime that goes into 150? Well, 2 goes into 150 and gives me 75. What's the smallest prime number that goes into 75? 3 goes into 75 and gives me 25. What's the smallest prime that goes into 25? Well, 5 goes into 25 and gives me 5. Since 5 is prime, it's going to bring me to 1. When I get to 1, I know I'm done. So now once I finish my factor ladder, I'm going to circle matching pairs. Well, I have a pair of 2's, I have 1, 3, and then I have a pair of 5's. So I'm going to take my 2 and my 5 and put them on the outside of my square root sign. And then I'm going to put this leftover 3 on the inside. So I took my pairs and I put them on the outside and I multiply them together. Well, 2 times 5 gives me 10 times the square root of 3. And this is simplifying the radical of the square root of 300. So let's look at this one. It says the square root of 51. Well, if I get to 51 and I start thinking about, okay, 51 divided by 2. Well, that gives me a crazy decimal. 51 divided by 3. Well, 51 goes into, 3 goes into 51. And gives me 17. Then 17 goes into 17 because 17 is prime and gives me 1. Well, what if I don't have any pairs? Do I have any pairs? No. So my non-pairs stay on the inside of my radical. And that just leaves me with my starting answer. So sometimes you could do your tree and you could get no pairs, which leaves you with your starting question as your answer. There's no way I can simplify the square root of 51 if I do simplifying the radical. Another time this can happen when you end up with your answer is if it's prime. So let's say nothing goes into that number besides 1 in itself. You would end up with this case again where your question matches your answer. Let's try 220. The square root of 220, so I have 220. Well, 2 goes into 220 and gives me 110. 2 goes into 110 and gives me 55. Well, 5 is the next smallest number that goes into 55. That's prime, and it gives me 11. Uh-oh, is 11 prime? Yep. So I get to 1. When you get to 1, you know you're done. So I circle my pair on the outside, and I put one of those on the outside of my radical. My remaining numbers that are not pairs go on the inside, and 5 times 11 would be the square root of 55, and I bring down my 2 on the outside. So this is simplifying the radical. We've just gone through several examples. Now keep these kind of at the front. Make sure you look back at these. And I want you to try the next few on your own.